Welcome to another lesson for today. And today we shall be taking the number-based system. In the last class, we concluded that there are a lot of digital number systems that are available in the digital technology world. And the most common of them is the decimal number, which we know, that is counting from 0 to 1, 0 to 9. So today's lesson is the number base. So we're looking at different types of number base. And we have said we have the decimal, okay, which is 0 to 9. We have the binary, which is zeros and 1. This is the binary. And then we have Octal, the Octa system, another popular one. 0 to 7, and we have the hexadecimal, 0 to 15. So this is the hexadecimal, 0 to 15. So these are some of the systems or counting systems that are used. However, the binary number system is the most important one in digital systems, but several others are also important. The decimal system is important because it is universally used to represent quantities outside a digital system. This means that there will be situations where decimal values have to be converted to binary values before they are entered into the digital system. In addition to binary and decimal, two other number systems find widespread application in digital systems. The Octa system, I mentioned, popularly known as the base 8 system, and then the hexadecimal system, popularly known as the base 16 number system. These are both used for the same purpose, to provide an efficient means for representing large binary systems. Now we shall learn how to perform some of these conversions from binary to decimal to octal and to hexadecimal. Because when the strings becomes much, then we use the bigger values, which we are going to be seeing, bigger number systems. So let us start by learning how do we convert binary to decimal. There are different techniques I shall be showing you. However, I will start with the popular one we know. Let's say we convert 1011. This is an example of a binary system, 11010. How to convert it to what? To decimal. Okay? Because the decimal system is what we use every day to count. So with this example of the binary, we want to convert the binary to what? To decimal. So using our traditional method that we know, we start by bringing out the numbers 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1, that is 1, 1, 0, 1, and then we now have 1 times 2 raised to the power 0. Okay? So this is it. So 2 raised to the power 4, 2 times 2 into 4 places is 16, plus 1 times 2 raised to the power 3, that's 8, plus, of course, everything times 0 is 0. Go ahead and solve some. The next one is decimal to binary. How do you convert decimal back to binary? The traditional way of converting this, still using the same example, is to have our 27, and then we divide all the way with 2. Okay? So 2 into 27, this is 1, and this is 13. Remainder 1. You have 2 into 13 is 6. Remainder 1. You have 2 into 6 is 3. Remainder 0. 2 into 3 is 1. Remainder 1. And then 2 into 1 is 0. Remainder 1. So you read from down to up. You take it this way. So your final answer will be what? 1, 1, 0, 1, 1. So you can see this is equivalent to this. This is base 2. So this is taking 27 to what? To base 2. Okay? So this is how you do it. Now there's another method I would like to share, a faster method with you. How to do that. Okay? This is what many of us may have learned in school. So there's another method. You write it this way, you have 0. This way is incrementing by 2, double what you have. We have 2, we have 4, we have 8, we have 16, we have 32, we have 64. You can see double of what you have. This way is dividing what you have. Okay? And just like that. So if you have this in mind, and you are asked to convert, for example, 27, okay, to binary. So what you do is you look for the values of that 27. The values that you add up that will give you 27. You can see from here 32. 32 is greater than 27, so we'll start from here. So 16 is part of what will give us 27. Now 16 plus 8 is 24. That's 1. Drop it. 24 minus 27, you still have 3. So this cannot give us 3. This is 4. So we have 0. 2 and 1 will give us 3. That is 1 and 1. So can you see this is a faster method? So the equivalence of 27 is equals to 1, 1, 0, 1, 1. This is how we do that. This is a more faster method. For example, what if you are given 45, for example? Take 45 to base 2. Okay? This is like a formula for converting from every number base. So let us apply it here. What of 45? Given 45, 32, 64 is more than 45, so we'll go with 32. So when we have 45 minus 32, we have 3, 13. Okay, so this you have 1. Okay, so the next thing is we are left with 1, 13. 16 is out because it's more than 13. We have 8. Okay, so 8 is part of it. So 8 minus 13 will give us 5. So this is still within it. 4. This is more than that. 1. So can you see that? So 32 minus 45 will give us 13. 16 is more than 13, so you have 0. 8, 4 is what? 12. And then 1, 13, which is not 1. So the faster way to do this, 45 is equals to 1, 0, 1, 1, 0, 1. So this is the equivalent of 45 in what? In base 2. So this side is for the fraction. And if you have some fraction, you will do what? You will use this question. The other example we are going to be looking at is the other side, the fraction side. So what if you are given 45.53, okay? You can see that this is a fraction, the decimal part of it. So which means you are going to increase this to accommodate what we need. So we take the, we said you keep dividing this by 2. So 0.5 divided by 2, you get this. You divide this by 2, you should be getting something like 0.0625. Okay. When you divide this by 2 again, you should have something like 0.03125. Something like that. So you keep going. So for this example, we have established the 45. I hope you understand that part. So we have the 101101 point, the 53. So we go to the other section. This is 0.5. I hope you know that this is 0.53. Okay. So what will give us 0.53? This is one of them. 1. So this The remaining one will now be, if you take out 0.5 minus this, you now have 0.03. Okay, take out 0.5 from it, so you have 0.03. So the nearest nearest answer that will give us this is above that, this is above that, so this is closer to it, this is 0.03. So you have a 1 here. So this will be 0, this will be 0. Okay, so the full answer will be 1001. Okay, so this means that 45.53, the equivalent is 101101.1001. So this is the answer in base 2, that is in binary format. So this is how you can do your conversion. Look into your text for further examples and exercises. Now let us go into octal number system, popularly known as base 8. So it means that we count from 0 all the way to 7. And then we are going to look at the octal digits. Look at the octal digits, definitely we run from what? From 0 to 7. And then the binary equivalent, the binary digits. Okay, so this table you must know, because you are going to group them in trees. Octals are grouped in trees. You group the binary numbers in trees. So we have, starting from 0, 0, 0, 0. Okay, 1 will be 0, 0, 1. 2 will be 0, 1, 0. And then number 3 will be 1, 0, 0. Okay, or that's 0, 1, 1, 0, 1, 0, 1, 1. 4 will be 1, 0, 0. 5 will be 1, 0, 1. And 6 will be 1, 1, 0. And then we have 1, 1, 1. Okay, so this is it. This is how it is grouped. Now, one could have asked, how did I get these digits? These are just the normal way you can, when you get the binary equivalent of this. For example, we have 2, okay? 2 into itself is 1, remainder 0. 2 into 1 is what? 0, remainder 1. Then you take it up. So you have 1, 0. Of course, to make it 3, add 0 in the front. So whatever number you add in the front of any digits renders it doesn't mean anything. Just like you have 3 and you say 0, 3 is still 3. 0, 4 is still 4. Okay, so whatever number you add in front of any digit, be binary or decimal, doesn't really make much difference. It's when you add it after that makes much difference. Now, for example, we are now asked to convert 1, 0, 0, 1, 1, 1, say 0, 1, 0. Okay, convert it to octal. Okay, so change this to octal. So once octal is mentioned, you should know that we are referring to what? Base 8. Okay, so how do you do this? You group them in threes. Okay, starting from the back. So you take 0, 1, 0, this is 1. 1, 1, 1, that's another. And 0, 0, 1, this is another one. Okay, so this is how you group them in threes. So having this table at the back of your mind, you just cross-check them. What is 1, 0, 0? 1, 0, 0 here means what? 4. 1, 1, 1 means what? 7. And 0, 1, 0 means 2. So the answer is what? 4, 7, 2 is 8. Is 8. Now remember, there's other method I just showed you how to convert this. What if you're asked to convert octal back to decimal, back to binary? So how you do that is you group them in trees, just this way, and then you write another method. You write 0, just like I told you. Remember, 0, you have incremental 1, 2, 4, 8, 16, and so on and so forth. So this is the same way what to apply here. You have this is 1, this is 2, and then this is what? 4. Here again you have 1, 2, 4. Here again you have 1, 2, 4. Just that way. Now, the ones that have 1 in between is what you are going to consider. Of course, 0, anything raised to 0 is 0, anything multiplied by 0 is 0. So if you can see, here is only 2. Under here is 2. So the answer here is 2. 1, 1, 1. You are going to consider everything. So we have 1 plus 2 plus 4. That will give us what? 7. Here, 0, 0. We are not going to consider this. We have 1 here, so we are going to consider the number at the top. So we have 4. Okay, you can see it's the same thing. So we have 4, 7, 2 is 8. So this is another way of converting, a quicker method of converting the digits to octal. So this is how you do it. So what we have done just now is converting binary to octal and octal back to what? To binary. So we are going to be looking at the other converting methods like the hex. What if it is a hex? You asked to convert into hex. That's the base 16. Let us look at the other popular one, which is known as the hexadecimal. The hexadecimal, popularly known as the base 16. What it means is we count from 0 to 15. Now, unlike the octal, where you group in 3s, for the hex you group in 4s. Now for the hex system, from after 0 to 9, now from 10 to 15, because you say from 0 to 15. Now from 10 to 15, you label them, or it is labeled or categorized in alphabets. So 10, we refer 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as what? F. So this is how we label the hexadecimal system. So after 0 to 9, the conventional one, 10 to 15, this is to differentiate it, so we know that this is not decimal. So this is how it's organized in hexadecimal. So take for example, we are given numbers, say 10, 10, 10, 10, 2, 4, 6, 8. We are given this to convert to what? To hexadecimal. How do we do that? I said we group it in 4s. So how do we do? We start from the back. 1, 2, 3, 4. We group it. 1, 2, 3, 4. Okay. So what is 1, 0, 1, 0? What is 1, 0, 1, 0? Okay. Let's say we don't know that. So using the method I just showed you, the other method, 1, 2, 4, 8. Okay. 1, 2, 4, 8. Very tiny on top. So remember I said we consider the ones with the ones. Okay. So that of the 0 we are not going to consider it. So this we have 1 under 2 and 1 under 8. So we do what? 8 plus 2. 8 plus 2 is what? 10. Okay, here the same thing. 8 and 2 has 1, so we consider them. 8 plus 2 is what? 10. So we have 10, 10. Okay, and what is 10 under the counting sequence for base 16 is A. So in other words, the equivalent of 10, 1, 0, 1, 0, 1, 0, 1, 0 is A. Now the equivalent of this is what? A. So once you have seen A, it means it tells you that this already is in the what? Hexadecimal number system. Okay, so this is how you do that. So in your exercise as a practice question, when you take a look at your screen right now, you will see a practice question for yourself. I would like you to go through the 4 examples. So this will further illustrate whether you understand what we just discussed on how to convert to the various number systems. like from the octal to the decimal and to the hexadecimal. Okay, so when you do this, or when you have practiced this, you would have gained the absolute control over converting from one number base to the other. Thank you very much. Until we meet in the next class.